Welcome to BDB, a modern, unified, and integrated data analytics and AI platform. At BDB, we empower businesses to unlock the true potential of their data. With cutting-edge analytics, seamless integration, and AI-driven intelligence, we help you transform raw information into real insights. Let's walk through on how we integrate Genesys conversational data using an automated API pipeline into our PostgreSQL database. This process ensures that we can efficiently manage and analyze customer interaction data from Genesys in real time, enabling smarter decision-making and operational insights. Throughout this video, we will cover the following key areas of the integration process: API integration and data transformation. We'll show you how we fetch data via API, transform it using Kafka events, and store it in the database. Database tables. We will explore the Genesys tables, where the data is stored, and look at the tables like Genesys_stores, Genesys_agents, and Genesys_interactions, etc. Data agent conversation. Next, we'll see how the data agent can analyze the data and provide real-time insights, such as the most frequently used wrap-up codes and SLA breaches. A report. Finally, we'll recommend useful report that help you go deeper into the data and gain actionable insights. Walk through how we use an API-based data pipeline to ingest Genesys conversational data and load it into a PostgreSQL database. Let's go step by step through the process of configuring the components, handling events, and writing to the database. Let me walk you through how we configure an API component in the BDB platform to fetch data seamlessly. Here, we have the Meta Information tab of the API component. We start by specifying the source name, which in this case is Genesys_conversational_data. This tells the platform where the data will be sourced from. Next, we define the URL from which we will retrieve the data. For this demo, we are using a sample Makaru API endpoint, but in production, this could be your live API endpoint. Under query params, we specify two key parameters. Count, the number of records to fetch, here set to 1000. Key, a unique API key, 3785 CFB0, for authentication. These query parameters are essential for defining the scope of data we want to fetch. Moving on to headers, we need to add the accept header. This tells the API that we are expecting the response in CSV format, which is specified here. Headers can be customized based on the API requirements, and in this case, we're requesting data in CSV. For authorization, we've selected no auth, but for more secure APIs, this could be set to OAuth or API key. Finally, in the iterations field, we set it to 1, meaning the request will run once. You can configure the delay between iterations if you plan to run it multiple times. Once configured, the API request will fetch the data from the specified URL, using the query parameters and headers provided. Next, we have added Kafka event where we'll get data once REST API component process the data, writing to PostgreSQL database. To persist the data, we use a DB writer component configured to write into a PostgreSQL database. We've specified all the required credentials, selected the appropriate driver, PostgreSQL, and provided the schema and table names. The DB writer fetches the data from the Kafka event and writes it directly into the configured table. Each incoming payload corresponds to a different entity and is stored in the respective tables. Once everything is configured and mapped, we activate the pipeline. The system begins fetching data from the API, pushing it through the Kafka event queue, and writing it to the designated PostgreSQL tables. Data ingestion is now seamless and automated. Once the data is ingested using our pipeline, it's securely stored in the PostgreSQL database within the BDB platform. Now let's take a quick look at how this data is structured. Here in the data center, you can see the Genesys solution connector. This connector links directly to our PostgreSQL database named retail_cdp_solution, where all our contact center data resides. On the right panel, we can view the tables associated with this connector. As you can see, under the Genesys_conversational_data schema, we have a rich set of tables organized to support our retail contact center insights. For example, we have Genesys_stores, containing store metadata, Genesys_agents. For agent details, Genesys_customers, Genesys_queues, and the key fact table Genesys_interactions, where all customer agent conversations are logged. These tables are populated through the data pipeline and form the foundation for all downstream analytics, insights, dashboards, and data agent queries. With this structure in place, we're now ready to explore real-time KPIs, SLA performance, agent productivity, and much more. Let's dive into a quick demonstration of how data agents are revolutionizing the way retail contact centers explore data. Forget about struggling with complex dashboards or waiting for reports. Simply ask, and the agent delivers the answers. In a retail contact center, agents handle thousands of customer conversations daily. But what if they could access deep insights on performance, queues, and SLAs in real time, just by asking? Let me show you how a contact center agent uses the BDB platform to gain operational clarity and improve service levels, without writing a single line of code. Instead of navigating through complicated dashboards, I'll interact directly with a smart data agent. Here, we're using the BDB platform, which connects our data agents to all retail contact center interactions. I'll simply ask our agent, which wrap-up codes are most frequently used across all queues? The agent, which has access to our Genesys data, immediately begins analyzing all available conversation data from across our contact center queues. In just a few moments, we've got our answer. Here are the most frequently used wrap-up codes across all queues. As you can see, product inquiry is the most commonly used wrap-up code, with a total of 5,381 occurrences. This indicates that a lot of customers are reaching out with questions about our products. Right behind that, we've got technical issue and loyalty points being highly mentioned too, suggesting customer concerns in those areas are also significant. Looking at these wrap-up codes, we can see there's a fairly even distribution of concerns across several categories. This gives us a diverse range of customer issues being handled by our agents. Also provided query. Now that we've got our insights, here are some recommended dashboards/reports for further analysis. Now let me ask the agent. Show me the queues with the highest SLA breaches during peak hours where immediate operational action is required to improve performance. Here's the result. The two queues with the highest SLA breaches during peak hours are Q1, Loyalty and Rewards. 58.38% SLA breaches, 1,529 out of 2,619 interactions. Q2, Sales Support. 56.72% SLA breaches, 1,510 out of 2,662 interactions. Let's break it down. The Loyalty and Rewards queue has the highest percentage of SLA breaches at 58.38%. This means that more than half of the interactions in this queue are missing the service level targets. Similarly, Sales Support comes in closely behind with 56.72%. Both of these queues show a high volume of missed SLA targets, which signifies that something needs to be addressed to improve efficiency and response times. That's how we can analyze and act on critical performance data. By identifying and addressing these SLA breaches during peak hours, we can ensure we're always providing top-tier service for our customers. Let's make this happen. Here are the queues with the highest SLA breaches during peak hours. Here provide actionable steps or suggestions based on the insights gained from the data. Set up real-time monitoring to get alerted when a queue is about to breach its SLA, allowing quick operational adjustments. Once triggered, an automated email notification is sent to the configured email ID, ensuring the right teams are informed instantly for timely action. Suggest some dashboards and reports that can help monitor the queue's performance going forward. Let's take a quick look at the lineage graph for our Genesys solution in the BDB platform. At the foundation, we start with the retail_CDP_solution database, which is the main source holding all our customer interaction data. Next, we see the Genesys Solution Data Connector, which acts as a bridge, connecting this backend database to the rest of our ecosystem. From the Genesys connector, we have two key components branching out. Genesys_Retail_Contact_Center Data Store. This is where all the enriched and structured conversation data resides. It includes around 30 attributes such as QIDs, wrap-up codes, SLA status, and more. Breach Alert Peak Hours function. This function is responsible for monitoring SLA breaches during peak times and triggering alerts when thresholds are exceeded. On the far right, you'll notice the Retail Contact Center dashboard. This is the final output layer, which leverages the data from the data store to visually present performance metrics, like SLA compliance, sentiment distribution, and agent outcomes. This lineage graph provides a clear, end-to-end view of how data flows, from raw ingestion to actionable insights, within the BDB platform using the Genesys Solution Connector. Thank you for watching our walkthrough of the BDB Decision Platform. We hope this gave you a clear understanding of how we use API integration to fetch Genesys conversational data and transform it through our automated pipeline, turning raw API data into real-time insights and actionable intelligence.